Today we're going to look at linear programming. And your note sheet says many real-life problems involve the process called optimization, which is finding the minimum or maximum value of something. For example, a company may want to maximize its profits. So we're going to learn how to do this optimization of finding minimums and maximums by a process called linear programming. A little linear programming model consists of a few things. One is a system of constraints, so the things that companies are kind of restricted by, such as time, money, equipment, those types of things. And we're going to use linear inequalities to show those. There's also going to be some objective function that we're going to use at the end to figure out what's the min and max. When you solve one of these linear programming problems and you want to find these, there's kind of a process we go through. First, you want to graph a system of constraints. You have this example problem over on the side next to your notes here that has a graph of some constraints. So they've graphed these constraints out for you. Y equals 2, that's this horizontal line going across at 2 with the slope of 0. That one's greater than, so it would be shaded above the line. And then you got these two equations below that that are in slope-intercept form. Both of them have a y-intercept of 5. One has a slope of down 1 over 2, the other one down 1 over 1. And they are graphed on here as well. So these two lines. Okay, so once you graph, then you need to shade. And you want to test points out, just like we did in the previous section. 0, 0 works, see if it's true or not, and shade in. And they found that when you do that, all the overlap and shading happens in this triangular area right in here. That area is called your feasible region. So the overlap in graphing, the area that gets shaded by everything, is called your feasible region. It's called that because all your feasible or possible points occur in that area. All right, so once you found that, step 2 is to find the vertices. So vertices are any corners or points where lines intersect around that feasible region. This one happens to have 3 of those points. There's a point where the bottom 2 lines intersect there. There's a point right here, a vertex, and there's one other point right here where they intersect. So then you want to find out where are those 3 points located. All right. In this problem, this one on the y-axis would be at the point. You can just see where they intersect there. Both of them had a y-intercept of 5, so that point's at 0, 5. There's another one over here at over 3 up 2, so there's a vertice at 3, 2 right there. And finally, there's one over here at 6, 2. So those would be your 3 vertices for this one. The final step is to take each vertex and find the minimum and maximum. In the problems you're going to see, they're going to give you some kind of objective function. And that would be some kind of like pricing type function where that's maybe where they sell, the amount they sell these different objects at or whatever it is. But some objective function. What they look like, I'm just going to make one up for this. It might look something like this. Okay, so your objective function, this one would be a function where you plug in x and y, and the function itself would be 2x plus 3y. So if you want to find your min and max, what you do then is take your vertices, put each one in, and see which one would give you the maximum amount and which one would give you the minimum amount. So if we put these numbers, the vertices from these ones in, for 0, 5, if we put those in, we would get, so the function at 0, 5 would equal 2 times 0 plus 3 times 5. We get 15. You want to check all 3 points, or however many vertices you have. If we put 6, 2 in, we'd have 2 times 6 plus 3 times 2. So that would be 12 plus 6 is 18. Finally got to check the last point. If we put 3, 2 in, we'd have 2 times 3, which is 6, plus 3 times 2, which is also 6. That would be 12. So the minimum amount for this one, the minimum would be a value of 12. The maximum amount, if you wanted to get the max, would be 18, and it would occur at 6, 2. So min and maxes could be found at the end once you know where the vertices are. And that's kind of the process we go to. Let's try an example. Number 1, they want us to graph this system of inequalities out, find the vertices, find the feasible region, and then find the maximum and minimum values. So we start out with these constraints. We want to graph these out. Recall from yesterday, anytime you get an x equals line, that's a vertical line. So this first line we're going to graph is vertical. The y equals 1s, those are horizontal with a slope of 0. So let's graph those two out. The first one, find where x equals 1 is, find that x-intercept. That's going to be a vertical line through there. The next one, y equals 0. That's a horizontal line with the y-intercept of 0. So that one's going to look like this. And then finally, we got this last line. Now, to graph this last one, you could use the cover-up method to find a couple points. We could get it in slope-intercept form to graph it. Either way you want to do it. Let's get this one in slope-intercept form. So if we subtract 2x from both sides, we get the constraint, y is less than negative 2x plus 6. So let's graph that out. That would have a y-intercept of 6 and a slope of 2. So down 2, right 1, down 2, right 1, down 2, right 1, etc. So now we have our three constraints graphed, but we have not shaded. We need to shade for these two. For this last one we just graphed, let's test a point. Let's test out 0, 0, the origin, and see which side we should shade on. So if you put that in, you get 0 is less than negative 2 times 0, 0 plus 6 would be 6. So is 0 less than 6? That's true. So we want to shade on the side of 0, 0. So that one would get shaded everything to the left of this line. Okay. Looking at the other ones, y is greater than 0. That would be everything above this horizontal line should get shaded. And x is greater than or equal to 1. That's everything to the right of this line. So it looks like the part that gets shaded by everything would be this little triangular region. That's our feasible region. Okay, so we found the feasible region. Next, we want to find the vertices. Where are the vertices in this one? So it looks like there's 3, kind of like the last example we just looked at. 1, 2, 3. Find where those points are at. So looks like we have a point at 1, 0. There's another point here at 3, 0. And there's another point here at 1, 4. So those 3 points, those are our vertices. Okay, once you have your vertices, you want to now check them in with the objective function. So we want to take our objective function right here and see which of these points gives us our maximum and which one gives us our minimum. So to test them out now, you put them in. So we want to see what is f at 1, 0. Plug that in, you get 3 times 1 plus 0. That would equal a value of 3. We want to do it at 3, 0. That would give us 9. And finally, at 1, 4. And that would equal 7. So what's our minimum and maximum? Our minimum for this problem would be a minimum of 3, and it occurs at the point 1, 0. And our maximum looks like the biggest number is 9, and that occurs at the point 3, 0. So that would be the answer to this one. All right. Problem 2. We want to look at this one as well. Another problem where they want us to graph out a feasible region. Why don't you pause it quick, try graphing these lines on your own, and then we'll check them here in a second. All right, these are what the line should look like. Remember that this first one is a vertical line. So you should have that vertical line over there. The bottom line is just in slope-intercept form. This second one might be one where you had to do a little bit of rearranging. So if you didn't get that one graph right, remember you want to solve it for slope-intercept form. Subtract 3x to the other side. And then we still have a negative in front of this, so you got to divide by everything by -1. And when you do that, you get positive y, positive 3x, because 2 negatives makes a positive, positive 2 again, 2 negatives make a positive. And anytime you divide by a negative, you need to switch the sign. So those are our graphs. Now, again, we got to shade in here. So we want to do a little shading and figure out where is our feasible region on this one. If you test out the line we just did with a point like 0, 0, you get that 0 is less than or equal to 2, which is true. So we want to shade for that one. So we want to shade on the side of 0, 0, which would be right here. Okay. For the third line, test the point 2. If you test 0, 0 on this one, you get 0 is greater than or equal to -2, also true. So that one you also want to shade on the side of 0, 0. Which should be there. And then the vertical line, you can just look, it's less than 2, that would be to the left. So that would be shading everything here. So it looks like our feasible region occurs in this triangular region right in here. So that's the feasible region for this one. All right, once you have the feasible region, now you want to find the vertices again, and you can see where do those points intersect at on your graph. We have 3 of them here. Again, one is at 2, 0. There's another one up here that's intersecting, and that one occurs at 2, 8. And finally, we have one in this lower region, which is at -2, -4. So those would be the 3 vertices. Now you got to check those vertices with our objective function to see what's our minimum and maximum. So if we plug those in, we get 2, 8. So doing a little math, you got 4 minus 24, that's going to be -20. Put your other points in, 2, 0. Doing some math there, you get 4, and finally check it with the last point, -2, -4. Be careful here on this one, 2 negatives on that second one would make +12. So you got -4 plus +12, which comes out to be 8. So now to answer the question, you want to see what is your minimum and maximum. On this one, our biggest value, our maximum is 8 at the point -2, -4. And our minimum, our smallest, is -20. And that occurs at the point 2, 8. So that would be the answer for that one. So you want to find where's your min and max. All right. For this last problem for tomorrow, I want you to try reading through this one and see if you can find out some inequalities on your own. And for this problem, we're going to say X is the number of office visits. And we're also going to say that Y is the number of surgeries. So read through that one. See if you can for this one, do step 2 and write some inequalities for this one before tomorrow.